volume, which is mainly going to cover surface area of cylinders. So to start us off, we're going to talk about the parts of a cylinder. Okay, the circles of a cylinder are our bases. Okay, and then the height. Remember, height is the line that connects the two bases. So if we're looking at the net, then the height is going to be this line going this way. So it depends on where your circles are at. If your circles, are top and bottom, like left and right, then your height would be right there. Okay, if your circles were right here, then this would be your height. Okay, so it depends on where your circles are at. So depending on where your height is. For the radius, okay, we know radius and diameter. Radius is half the distance across the circle. Diameter is all the way across the circle through the middle point. Okay. The axis of your cylinder is what connects the middle of the two bases. Okay, so it is in a cylinder, or in a right cylinder, one that's upright like this, the axis and the height are the two main things, because the height is the line that goes straight from the top of one of the bases straight down. Okay, and I'll show you an example of what I mean here in a second. Okay, so on this one we want to identify the bases, the axes, and the height. Okay, so our bases then are going to be circle D and circle E. Okay, remember our bases are the circles. Okay, so D and E are our bases. Okay, our axes, okay, or axis, right? That's what connects the two circles in the middle of the circle. So that would be, and remember, your axis goes on forever, okay? It doesn't stop. So when we label the axis, we would say DE, and we put this line over it with the arrows that show that it goes on forever, okay? Now the height, okay, is just segment DE, all right? We don't show that the line goes on forever because the height is from the top to the bottom of the two bases, okay? So now over here, this is an oblique cylinder, okay? See how it's kind of leaning towards the side? Okay, so our bases here are still these circles, circle W and circle X, okay? Now remember, the axis is what connects the middle of the two bases, and it goes on forever, okay? So our axis then is going to be WX. All right, now the height goes from the middle of the top straight down. So it doesn't always connect in the middle on both. So if it's an oblique here, see how it starts at W, but it goes straight down to point Z. So actually the height of this cylinder is WZ. Okay, so remember, height has to make a right angle, but the axis does not have to make one. Okay, so the surface area of cylinder. I'm going to give you a different formula than this, but we're basically going to go back to this. I'm going to show you how we use pH plus 2B, because this is surface area for prisms. Okay, now remember, a cylinder is not a prism, okay, because it is not made up of polygons, right? A cylinder is two circles, one on top of another. Okay, circles are not polygons. And then the lateral surface area is one rectangle that's bent around the circle. Okay, so it's not made, the lateral faces are not made up of separate rectangles. Okay, but P again stands for perimeter of the base, and B stands for area of the base. All right, so surface area of a cylinder is going to be 2 pi RH plus 2 pi R squared, okay? And let's just break this down and think about this for a second, okay? P is the perimeter of the base, okay? Now, our base is a circle, right? Okay? What do we call a perimeter of the circle? The perimeter of a circle is just the circumference, right? And to find the circumference of a circle, we use 2 pi R. So the perimeter of a circle is going to be 2 pi r times the height of the prism. So that's where we get 2 pi r h, okay? Now, the other part, 2 times the area of the base, okay, there's our 2. Now again, let's look at the base, okay? Our base is a circle. What is the area of a circle? Well, it's pi r squared. So that's where we get pi r squared right here. So the formula for surface area is 2 pi rh plus 2 pi r squared. Okay, so we're not really going to ever use pH plus 2b, but I'm kind of showing you how this formula is derived from that other formula, okay? And obviously R is the radius and H is the height of the cylinder. And remember, the height is what connects the two bases, okay, right here, this purple line. Okay, so on this one, we want to give exact answers in terms of pi and the approximate answer using 3.14 for pi. So what it's telling us is one case it wants us to leave pi and one case it doesn't, okay? So remember, surface area is 2 pi RH plus 2 pi r squared. Okay, so we're just going to plug these in. 2 times pi times r, that's the radius, is 25, times the height, that's the line that connects the two bases, so that's 12, plus 2 pi r squared, so that would be 25 squared. Okay, so now we're going to solve this out, but we're not going to use pi just yet. Okay, so we're going to say 25 times 12, which is 300, and then we're going to take that times 2 as well. So that's 600 pi. All right, and then we're going to do 25 squared. So that's 25 times 25, which is 625. We're going to multiply that by 2, which is 1,250 pi. Now, since both of these have pi, right, we can call these like terms, then we can add this 600 and this 1250 together. And that's going to give us 1,850 pi. Okay, so that's our exact answer right there. Now it also wants to give an approximate answer. Okay, so what we're going to do now is times 1,850 times 3.14, and that's going to give us 5,809. Okay, so, oh, and excuse me, millimeters squared. Millimeters squared. Okay, so these are our two answers. This is exact, this is approximate. Okay, so again, same thing. It wants to give exact and approximate. So we have surface area equals 2 pi RH plus 2 pi r squared. So we're just going to plug in here. 2 times pi times r is 12, right? The radius is 12. The height is 30. And then 2 pi, again, the radius is 12 squared. So now we're going to take these two, 12 times 30, which is 360, and then we're going to multiply that by 2, which is 720. So we have 720 pi. 12 times 12 is 144, and then we multiply that by 2, and we get 288 pi. And now, since these both have pi attached to them, we can just add the 288 and the 720, and then we'll keep the pi at the end. So our exact answer is 1,008 pi centimeters squared. Okay, for our approximate answer, we're going to take 1,008 and we're going to times it by 3.14, and that's going to give us 3,165.12 centimeters squared. Okay, so that's exact, that's approximate. Okay, on this one, we want to find the lateral surface area. Okay, give exact terms of pi and the approximate answer using 3.14 for pi. Okay, because it says Yasmin is making strawberry jam and she's storing the jam in glass jars that are 3 inches in diameter and 4 inches in height. If she wants to make labels to cover the entire lateral surface of each jar, how big must each label be? Okay, so she has these jars here. Pardon my jar. It's not the best. And she's storing jam in it, okay? They're 3 inches in diameter and 4 inches in height, okay? She wants to know how much it takes to cover the lateral surface area. So we're not going to cover the top and the bottom. Okay, so let's go all the way back here to the beginning. Okay, do you remember earlier when we talked about lateral surface area? It's only pH, right? It's only the first part because we don't care about the area of the bases. So if we're only taking the first part of that formula, then we're only going to take 2 pi RH. Okay, so what we want to know then is just the radius and the height. Okay, so they do give us the diameter, which is 3. So we want to cut that in half, right? Half of 3 is 1.5. And then we're going to take the height of the jars, which are 4. So now we're just going to multiply this out. First, it wants exact. So we're going to take 4 times 1.5, which is 6. And then we're going to multiply that by 2, which is 12. So our exact answer would be 12 pi inches squared, or how big the jars must be. But to get an approximate answer, that would be around 37.68. So we're just going to round that up to the nearest whole number and say 38 inches squared. And that's the end of surface area and volume of cylinders 1.